and currently I'm pursuing my PhD in aerospace engineering at the University of Bristol, UK. This is Chopade sir ने तो पहले ही बता दिया है, but I'll reiterate my journey from a very small town of Mugri. You can see that's my village and my house there, very small still. From Kagal to when I was 3 years old, I went to Ajra, which is my maternal parents' home. I was very lucky to come to Navodaya Vidyalaya Kolhapur in 2004, and I studied there till 10th grade, 10वीं तक. So 10वीं में जब मैं था तो Pestology International Village Trust करके एक a lot of people from Satara would know, a lot of people from Sangli also would know, and Kolhapur. So there is a charity called Pestology International Village Charity, and they select students from all over the world, 20 students from all over the world. And I was fortunate enough, thanks to Chopade sir, thanks to Jawahar Navodaya Vidyalaya, Kolhapur, I got that opportunity and I came to UK in 2009. I studied in this college, Sussex Coast College, you can see in this box, right? I did my 11th and 12th there, basically International Baccalaureate, which is International Board for 11th and 12th. Then I got another opportunity to study mechanical engineering. I did 2 years of mechanical engineering, 2 years of aeronautical engineering at the University of Brighton. I got a scholarship from the president of the university, Kulgurunchi scholarship I got. And then I went to do engineering with innovation and entrepreneurship at the University College London, UK. Meanwhile, I also worked as a data researcher in one of the biggest health organizations in the world, which is called National Health Services in UK. I also, meanwhile, worked in University of Manchester as a space scientist for a year, which is last year. And now this year, this year, September 2019, I have enrolled in space engineering in PhD. And this is me. That's my small journey. So today, without further ado, we'll begin. So what we're going to do today is look at a little bit of introduction. And my presentation today is mainly focused on science and research in space engineering, in flight engineering. Okay, so there will be less of slides and more of science and research. What is science? What is research? बहुत लोगों को पता नहीं है, बहुत लोगों को पता होना चाहिए. It's interesting, it's amazing. है ना? There are a couple of slides on the journey of avionics, like how we developed from like cave ages, Ashmayug se hum kaise, like we came to modern era, and how had science and research help us reach here. And I will little bit talk about my research at the University of Bristol also, and we'll conclude. I have few questions for you guys. You can just type in your chat box. They're not big questions. They're very, very small questions. So let us begin, and I hope you like it. So my first question is, how do you define science? Or what is science what do you think when somebody says science? What is the first thing that comes into your mind, or what is the definition of science you think? And you can put in your chat box. Anybody can do that. I'll give you like 30 seconds. Okay. Anybody? Yeah, great. Invention of everything. That's amazing. So that kind of captures the gist of science also. But I got this definition of science from Google. Yeah, Shubhda says systematic formulated. Amazing. Exactly. So Google says science is the intellectual and practical activity encompassing the systematic study of structure and behavior of physical and natural world through observation and experiment. Now, this is a very boring kind of, it's a very boring definition of science, but very, very precise as well. And I don't want you to remember this. There is no point of remembering this. What I want you to understand is look at those bold words. And those bold words say systematic study through observation and experiment. And that is what basically science is. Science is all about observations, science is all about experiment, right? So that is one point. The next question of mine is, how old do you think science is, or the field of science is? Now this is very, it is a number, so you can all can type. How old science is, you think? Like in terms of years, like 100 years, 200 years. Anybody? Okay. Yeah, that's great. So it's, you got it basically. Shubhada says age of the sun. Right. Great. So science has been around uh, as long as the universe is around. Yeah, beautiful, Mayuri. Like she says, science has been from the beginning of the world. Exactly. Science has been around since 13.8 billion years, which is the age of our universe. The active science. So before 2 lakh years ago, the science was there, scientific phenomena were there, but then there was no active science. And then active science came into existence when humankind evolved from through the process of evolution, and that is 2,000 years ago, which is 2 lakh years ago, right? And people started making stuff and using the formulations of science around 6,000 years ago. And third question is, if I ask you the 5 greatest discoveries of mankind, what could they be? What are the, like, you can say one. What is the greatest discovery of mankind so far? Fire, brilliant. Shweta says fire. Wheel, great. Hmm. Nice. So nice. So how do we know that science has been there, right? Science has been there, as I said, 2 lakh years ago, or 6,000 years ago. हमें कैसे पता है कि science था? And we know that because human created something for the first time artificially, and that was fire, right? Human also created something called wheel, and some human found out that farming was a way of sustainable living, and these are we might think today because we take it for granted, but these were the greatest discovery of mankind. Without this, we couldn't have probably dwell into the future, and we could have died as humans. So we looked at science as a systematic study through observation and experiment. And this guy, which is a brilliant scientist, brilliant astronomer, physicist, said that in science, opinions of thousands of people doesn't matter. Okay, what matters is the reason of one person. Okay, what he wants to say is, if 100,000 people say something, because before him, people used to say that sun revolves around the earth. Okay, but then Copernicus came and he said, no, it is the earth that revolves around sun. And he gave a very good reason. This guy, whose name is Galileo Galilei, we all know him through our science books and all other stuffs. He gave a very simpler idea of science, a very simpler notion, simpler definition of science. And he said, science is nothing but reason. Okay, and the evolution of science has happened because of one word, and that is why. Our ancestors, the greatest of great scientists like Einstein, Richard Feynman, Galileo, and so on and so forth, asked the question why. They wanted a reason behind something happening. Like they wanted to know why Earth revolves around the sun and sun doesn't revolve around the Earth, right? So the one word that push forwards the boundaries of science is why. And that is because Galileo said science is nothing but reason. So let's say all of you 40, 43, 50 girls tomorrow want to be scientists and want to develop a new law or develop a new theory. How do you do that? Right? And I am coming to a third, but a very precise and crisp notion, understanding of science, which is given by this handsome man, a brilliant physicist, one of the most genius scientists of 20th century, Richard Feynman, who got Nobel Prize in 1965 for his contribution to quantum mechanics. And he said that if you want to seek a new law or if you want to define a new theory or come up with a new theory in science, what you have to do is you have to take a guess. Okay, you take a guess, A. B, what you do is you then, using the existing material available to you or techniques available to you, you compute your guess. For example, and then you compare your computational results with your comparisons. So you compare either with nature or either with your experiments, right? So for example, a uh, very small example would be, I guess that this pen would write for 10 hours if I write it continuously. That's my guess. But then how do I compute? What are the parameters do I have? So I'll take the refill out. I'll say that the refill diameter is this, the length is 15 centimeter, the diameter is probably half a centimeter. Okay. The ball diameter is 1 millimeter. Okay. And I'll do some fluid mechanics on it. I'll do simple mass, velocity, all these things with it, right? And I will say, okay, this pen probably, I think it runs for 10 hours. If I guess, you have a computation, you do some, and then what you do, then you write it for 10 hours, write it until it finishes. Now, humanly, it's not possible. So probably you will have to build a robot which continuously just scribbles for as long as the pen goes on, right? And then you come up with the answer, and then the robot, that robot hand only writes this pen for 8 hours. And then you go back to your computations and say, okay, so my guess was wrong. Therefore, my computations were probably wrong. What can I change and how can I make my guess right? And so this is the process of seeking a new law. This is the process of being a scientist. You take a guess, you compute through existing computational knowledge, and then you compare it with nature. And this word nature and experiment is very important. I want you guys to listen to this. Listen to this definition of this definition from Richard Feynman himself. This guy is called. This is another brilliant scientist. He's Brian Cox. But I'll move forward to Richard Feynman. Can you hear?
In general, we look for new law by the following process. First, we guess it. Then we don't laugh. That's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply. And then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, wrong. That's all there is to it.
Yeah. So what he is saying is, to go back, you take a guess, you compute, and then you compare your results with nature or with experiment. And if your guess is wrong, then your law is wrong. And it doesn't matter who said the law. Even if Einstein stated a law, stated a guess, which didn't agree with the computational and experiments, then even Einstein is wrong. And many people at many points have proved, in some cases, not all of the cases, even Einstein is wrong. So that's what he's saying. He's saying that take a guess, compute it, and compare. And for me, the best definition to it. And I have two, and you, all the brilliant scientists of JNV, Kolhapur, Sangli, Satara, I have two science questions for you. And then one question is, you find the law of rice grains, where I want to find out how many rice grains would be in 100 kg bag. Okay, you can do it later. I'll and maybe send the answers to me later. But what I want you to do is, can you come up with an equation for it? And you know how science is. Science is universal, right? So if it applies to one bag of rice, it has to apply for all the bags in the world. Okay, so this is for vegetarian people. The next law I want you to find out is the law of boiling an egg. And I want to come up with a parameters and equation about defining or stating how long does it take to perfectly boil an egg. Okay, and remember, you're not at all allowed to touch an egg or bag of rice until you want to perform an experiment. So you first take a guess. You say it takes 10 minutes to boil an egg. Then you go and compute the results. And the way you do that, you say the shell is this much thick. The proteins inside are, you do some Google search and you say how long does a protein take to solidify. Okay, then you compute it, and then you go on and perform an experiment and say, okay, it takes so and so minutes. If you say 10 minutes, and if your egg is boiled in 9 minutes, it's still a good guess. Okay, it's wrong, but it's good guess, good start for experiment, or that. So let us move on to research. What is research? So first definition of science we saw was that science is a parametric study, systematic study through observation and experiment. And our brilliant Richard Feynman said to us, that science, to be able to define a law, you need to agree with nature. Okay, and research is nothing but that. And again, this is a very long definition of research, where it says it's a systematic investigation into study materials and resources in order to establish a fact and reach new conclusions. But all I want you to understand is research is systematic investigation to establish new facts or new conclusion. And the aim of research is to make something known which is previously unknown. Pehli cheez. Dusri cheez is, the aim of research is to push the human knowledge and boundaries of science. And a very important aim of research is discovery. Okay? Imagine, like, why do we do research? Because we want to discover something. Okay? So science में क्या होता है? There is one difference between science and research. Science is always into future, so it is pushing you into future. है ना? It's never taking you back. So science is unidirectional. तो वो आगे ही जा रहा है ना? Research on the other hand is bidirectional. So either you can research into the past, okay, or you can research into the future. And there are two very familiar words for research into the past and research into the future. Do you know what do you call research into the past? If somebody finds out something from the past, what do you call it? Anybody? Okay, I'll tell you. So research into the past is called discovery. Okay, right? Brilliant. And what is research into the future? It's innovation, right? Invention or innovation. So I don't think I need to explain a lot about that. But imagine laws of gravity are also always called, they are called discover, they are discovered because they are from the past. They have always been there. Somebody went and found it. But car is an innovation, or car is an invention. It's because before invention of car, there was no car. Okay, or somebody tomorrow, if somebody invents a flying car, that would be an innovation, right? So all of you are right, Akshata, Chaitrali, Mayuri, all of you, well done, Sweta. So I don't think you need any examples, but anyway. So, but I think that research is nothing but humans trying to catch up with the nature. And I have a very brilliant example for you that. Okay.
Cool.
So when we first discovered, or when we innovated flying machines, which is aeroplanes, it took us from the civilization, like say from the human civilization, which is 2 lakh years later. It took us almost 2 lakh years to to invent, to know how to fly. Okay. However, nature always knew it. The birds are almost 15 crore years. The birds, the earliest bird was found 15 crore years ago. Okay. So nature is always at front, and us as humans were trying to catch up. Okay. So another example is this. What happens is that scientists at NASA spend billions and billions of dollars developing a new form of steel which was completely frictionless. Okay, so that's one example. But they could only achieve the frictionless, so coefficient friction as minimum as 0.25. So they got rid of 75% of friction. Okay, that's a great achievement for humankind. But if you look at our elbows and the frictions between our cartilage and the bones, it's 0.01. Okay, so it's just 1%. So nature has got rid of already, through its amazement, 99% of the friction, whereas after putting 500 times piche hai nature ke, right? So the researchers and research is trying to, like through research, humans are trying to catch up with the nature. They're trying to copy nature. Like हमने birds को देखा, अभी हमने उड़ना है. हमने मछली को देखा, हमें तैरना है. We saw cheetahs flying, like running faster. हमें अभी fastest car बनाने, so on and so forth. हमने asteroids को देखा, and then we wanted to go to space and explore more space, more into space. So it's research is nothing but humans trying to catch up with the nature. Okay. And I really want you to think about these two things, where I want you to, when you go home, think about what is time. Okay, research into these two topics. What is time, and how our ancestors keep track of time before clocks were invented, or our Dinadarshika jo hai na, was invented, right? So there is a lot to be researched about in that area. Okay. So that's first exercise for you guys. You can ask me questions about this later as well. And the next question I want you to research is it possible for human beings to fly? I mean, not in an aeroplane or helicopter, but with minimum machinery attached to its body. Okay, or no machinery attached to its body. Or why is it impossible for a human to fly? Okay. So think about these two research questions, and we can discuss it later. So let us talk about the evolution of avionics, which is flying machines. Okay, so we know science is a systematic study of observation and flight and experiments, and research is nothing but humans trying to catch up with the nature. And through the evolution of avionics, I'm going to kind of prove to you कि हमने कैसे we have used science and avionics to do exactly that. I don't know how much time I have. Yeah. So great. So look at this, and this is the brilliant diagram made by me again. So again, 150 million years ago, there were birds. They were flying flawlessly. Okay. 500 years ago, brilliant artist, polymath, scientist, mathematician, biologist, okay, and physicist Leonardo da Vinci saw birds, saw a lot of things in the nature, and came up with this ornithopter, which is the first design of an aeroplane or helicopter. Okay, but then it took us another 200 years for human beings to know how to fly, and they still didn't. They didn't have. I'm looking at this balloon. Okay, so they still didn't know how to fly. They used the big balloons to go up and down, but they couldn't fly for longer. Okay, 100 years in the future, almost, and one guy called Lilienthal attached wings to his body, went on the cliff, and jumped and tried to fly. Okay, that is how insane human beings are. We just want to be like nature, be like other birds. That Lilienthal invented his glider. He got so many injuries because of that, because his flight was not successful. But then move forward another 100 years, maybe 20, 30 years, and Wright brothers had their first working aeroplane. Okay, another 4, 5 years, this Paul Cornu had first helicopter, and then another 40, 50 years, we sent first satellite into space. Another few years later, we sent first man onto the space. And now, if you look at this picture here, this is what is called orthocopter. It's because it has 8 propulsion system. It is a first design of a air taxi. Okay, we all know that there's lot of traffic on the road, so people are exploring in the area of flying small cars or drones which are as big as cars to take people from one place to another place. And this is where we are, and we don't know what's there in the future. Elon Musk and lot of other people are talking about going to space for holidays, okay, for picnics and so on and so forth. That is there, and they're thinking of going to Mars. They're thinking of going to Moon, live there, stay there, build hotels there. A lot of developments are already happening, but from 1485 to 2020, we have come a very long way, and we have done that because we have looked at nature, we have taken inspiration from it, we have used science and research to advance our human knowledge and human technology. Okay, so I will give you a very small example of how things happen. So we looked at birds. यहाँ पे we looked at birds. We say that the air goes above the air birds wings like this, in a curved manner, under the wing as a straight line. So if you look at this black aerofoil design here, you will say that when the air goes above the aerofoil, there is a low pressure area is created, and when it goes below, the positive pressure area is created, and that is how the aeroplane is lifted. Okay, and the whole point of that is, we looked at birds, we try to mimic birds, we come up with a design. The Wright brothers were the first ones to come up with the first successful design of an aeroplane. You can see how it was made up of wood. It was not as great. It only flew for 20 minutes, not very far, not very long. Okay, and as the developments in engine engineering, design engineering, fuel engineering, material engineering, electronics, computation happen, simultaneously you can see the modern Airbus A321 here, which is the modern aeroplane which can fly for non-stop 20 hours. It can accommodate almost 300 people. Okay, and it is amazing. The engine system is amazing. The flights is amazing. The materials they have used is very light, very sturdy, very hard, very tough. Right. So we took a very simple concept as bird. We re-engineered our wing, this black thing, okay, and we put it back in our human technology, human brain, human materials, and so on and so forth. And we came up with this uh, brilliant design of an aeroplane which works perfectly. And this is exactly what we call biomechanics, biomimicry. So we look at, and human beings have been doing it since ages, since the beginning of the world, right? So they are doing it for ages and years and years ago. We're looking at a biological thing, okay, and we're trying to mimic it in our own world. So this black thing is a, तुम्ही पाहिलं असेल, आपने देखा होगा, it's a seed of a maple tree, and when it falls down, it falls in a very circular motion, slowly, slowly, slowly. So when other leaves fall down, they fell down directly, but this maple leaf falls down really, really slowly. So the design or the idea behind the helicopter is exactly that. तो जैसे वो नीचे गिरता है तो एक सर्टन डिरेक्शन, सपोज एंटी क्लॉकवाइज घूमता है, राइट, तो नीचे गिरते हैं। तो हमने सोचा एज ह्यूमन बीइंग, व्हाट इफ वी रोटेट दैट थिंग इन क्लॉकवाइज डायरेक्शन। सो जैसे नीचे आता है, कैन वी लिफ्ट समथिंग अप इफ वी रोटेट दैट इन अ क्लॉकवाइज डायरेक्शन? And we exactly did that. Again, Leonardo da Vinci was the first person to come up with such a design. Again, 500 years later, developments in technology, and we got a helicopter. Now, हम helicopter पे भी नहीं रुके. We wanted taxis that fly. Okay, so we came up with this orthocopter. Now, when you look at this orthocopter, there are too many fans there. Okay, and it makes a lot of noise. Okay, so in future, if you look at this, there will be a taxi like this, and there will be only 4 fans. You can see there, and there will be almost very little noise compared to helicopter, because helicopter and this octocopter has very huge noise. And one of my research area is to work on a flying car concept. Okay, and I am particularly working on how do we reduce the noise for futuristic cars, because जब तक हम noise reduce नहीं करेंगे, तब तक we cannot use this as air taxis, because जैसे aeroplanes हैं and helicopters, वो तो बहुत they fly at a very high altitude, almost 30,000 feet. Helicopter तो उतना नहीं जाता, but aeroplanes are way above our houses. But these air taxis will be roaming around just maybe say 100 feet above our houses. And अगर हमने उनका noise कम नहीं किया, तो people will never accept the idea of flying taxis. So my research is basically that. So yeah, I just completed my point there. What is in the future? So the concept of air taxi is there. I am at the University of Bristol. Working, me and my team are working to do it. We're working with Uber, we're working with Google to make it happen. They are funding us, really. Google and Uber are funding us. The second thing in the future, in near future, is a space travel, and it can be possible in next 10, 15 to 100 years. If not for us, maybe our next generations can visit and spend holidays on Moon or on Mars. Right. Till then, though, our job is to keep exploring and keep learning, keep trying to copy nature, trying to learn from nature. And so I would conclude quickly here, because I want to have like at least 10 minutes for our Q&A. Is that what do we learn today? And I think we learned that science is all about understanding and learning from nature. That is, there we looked at 3 different definitions, 3 different interpretations of science. One was science is a study through observation and experiment, which is which is exactly right. Other one is science is nothing but reasoning, asking why. And third is that science is guessing and making an informed guess and trying to get validation from no one but nature, right? So you guess, you compute, and then you compare with nature or experiments. The second thing we learned today was research is about catching up with nature, really catching up with nature. For example, I was involved uh, in a project where we were developing artificial hearts made up of a different kind of material, which is, you can say, it's a cloth, basically a very different kind of polymer. Okay, uh, although that project was successful, that heart, when we transplanted into, I mean, it's not full heart, it's a part of heart. When we transplanted into a person, it only worked for 2 or 3 years and it failed. So you can see how research is about catching up with nature. And I think that that is research. The third thing is our human curiosity and thirst for knowledge have brought us here, and we need to keep continue as a students of science. We all need to continue being curious and keep exploring. And this is also to understand that we have only understood only 1% of the nature and universe, and there is lot to be discovered. Lot of times, lot of students ask me that यार इतने सारे laws बनाए हैं, इतने सारा मतलब already innovation invention हुआ है. Uh, what is there to research? And I think there is 99% yet to be researched, yet to be invented. So you girls who are listening here today have a great chance of making it big into science. We need we need women leaders in science these days. And I hope after this lecture, one of you will emerge as one of the scientific leader, not just for India but for the world. And that's it. Basically, this is, if you want to contact me on Google, Gmail, this is my Gmail, this is my LinkedIn, and this is my Instagram. So yeah, these are two really nice videos I wanted to show, but I don't think we have time. Yeah, so that's it. If you have any questions, you can ask me.
Okay, students, if you have any, you can just even you can directly interact by unmute your mic, or even we have 10 minutes. Okay, meantime I will ask Pravin. So what are the chances of getting scholarship abroad for the present students?
So it's a tricky situation right now because of Corona, but I would say there are a lot of opportunities after BSc. There is one thing called uh, so for masters and PhD, there are lots of scholarships. Okay, it is quite competitive, and there are lot there. So these girls are 12. What girls are this like? What class? So I took science like physics, chemistry, maths in 12th, and then I studied aeronautical engineering at the University of Bristol. Sorry, Brighton first. And although it was half mechanical, half aeronautical, I didn't learn much about it. So I went to University College London, and there I got chance to work on a satellite, very small satellite. So that's what to do is find anything uh, to go and do aeronautical engineering or BS in astrophysics or aerospace engineering, something like that. And then maybe for masters, try for universities in UK, USA, and I'll be very happy to. Is to reduce noise. That is the first thing. So if you have this wing, right? If the wing is going this it is generating a lot of friction. But we are looking at the next generation air taxis. We're trying to see if we can, these propellers, which is the fans. Okay, so we're trying to see if we can bend the, curves of the fan so that it reduces noise. I think so. Presently 12. So I think best way for them is to uh, again because of corona and all that complete their graduation in India, and then after graduation there are numerous opportunities. There is a Manmohan Singh scholarship at Cambridge. There is Ratan Tata scholarship in US. There are so many NGOs and so many governments that are offering scholarships. So yeah, lot of help, and it is helping millions and millions of people regardless of their status.
For our invitation and being with us
Uh,
all this time,
thank,
interacting and motivating our children. Hope we will meet again. So thank you so much on behalf of
thank you.
JNV Sangli Vigyan Jyoti Group.
Thank you. Thank you, sir.
Okay, guys. So thank you for joining. But still,